Let's discuss the today's problem of the day of Leetcode. Okay, minimum speed to arrive on time. So we have been given a floating point number hour, which is the amount of the time we have to reach the office. Okay, means till that time we have to reach the office. To commute to the office, you must take n trains in sequential order. We have to take n trains one by one to reach to the office within our number of hours. Okay, you are given you are also given an integer array distance of length, the dist of length, and where dist I describes the distance in kilometer of the ith train ride. So basically dist represent the uh, dist I represent the distance to be traveled by the ith train. Okay, each train can only depart at an integer hour, but there is a case that all the trains will depart only at an integer hour. Okay, so suppose if you depart with a train and you reach to a station where at a time of 1.5, then you will have to wait for half an hour to uh, to take another train. Why? Because of this condition, each train can only depart an integer hour. So so you may need to wait in between each train ride. For example, if the first train ride takes 1.5 hour, which I have discussed, you must wait for an additional zero point 0.5 hours before you can depart on the second train right at the 2 hour mark. Means if I wait for the zero point 0.5, then it will become 2. Okay, so now at 2 I can depart with another train. So return the minimum positive integer speed in kilometers per hour that all the trains must travel uh, at for you to reach the office on time, or -1 if it is not possible to be on time. Okay, so we have to suggest a minimum positive integer speed which all the trains should travel at, so that we can reach to the office on time. Okay, or we have to return -1 if it is not possible. Okay, test are generated that the answer will not exceed 10 to the power 7. Means the the minimum time at which the speed should travel will not exceed 10 to the power 7. Okay, so basically it's the upper bound of the speed. Now so let's discuss this test case 132, and we have 6 hours to reach to the office. Okay, so if you travel at speed 1, answer is 1, of course. So if you travel at speed 1, then 1 by 1 is equals to 1 hour, since time is equals to distance by speed. So the first train will take 1 by 1, distance is equals to 1, and time is equals to 1, so 1 by 1 is equals to 1. And the second train will take 3 by 1 is equals to 3 hours. And since all these are integers, so we can depart immediately. So we depart immediately at the 1 hour mark. We depart immediately at the 4 hour mark, because 1 plus 3, second train take 3 hours, so it has become 4 hours. And the last train will take 2 hours, so we can reach within 6 hours. Okay, let's discuss the second example. Here the answer is 3. Okay, now 1 by 3 is a floating number, so I can say that if I reach the next station at 0.333, so it is a decimal one, so we would have to wait until the time will become 1 hour. Okay, 1 hour. And now since we are not an integer hour, we wait until the 1 hour mark. That's what I have explained. The second train ride takes 3 by 3 plus equals to 1 hour. Now the second train will take 1 hour again, so now we have used 2 hours. Okay, so you should notice here that the last train was 2 by 3, 2 by 3. If I again uh, point, it would be 0.67. Okay, 0.67. So you can see that I can reach the office at 2.67. And why I have not converted this to the integer one, why I have taken accepted in decimal form, because I have already reached to the station. Okay, so in our implementation also, if it is the last station, if it is the last journey, I can accept that in decimal form. Okay, so that's all about the question. Let's discuss. One thing you should notice here, that I can just prove, if I am able to prove that this function, the time function is equals to distance by speed, the time function is monotonic, then I will be able to solve it using binary search. Okay. One thing you should notice here is that if I am able to reach to the station at a speed s, then if I decrease s, the time will increase, and if I increase s, the time will decrease. So obviously, if what I can say, time will increase. If I decrease speed, then I will require more time. Okay. So if I say that I can complete the journey in X time, okay, that I am able to complete this journey in X time, means I am able to reach the office on time. If I go to the speed S, then obviously I will be able to go to the office on time if I increase the speed. Okay. But if I decrease the speed, I am not sure about it. I am not sure about it because the time will increase now. So I am not sure about whether I will be able to reach the office on time or not. So that's the monotonic nature. No? I am able, if I am able to reach the office on time, if I go at speed as, then obviously I will be able to go to on on office on time at a speed greater than s. Okay, but I am not sure about s minus one. So that's the monotonic nature. So that's why I got the intuition about of the binary search. Okay, let's solve this. Int low is equals to 1 because the minimum speed possible is can be 1. Okay, it has been given positive minimum positive integer. Okay, and high is equals to, means the maximum bound of the speed can be 10 to the power 7. It has been given here. Okay, let's take one more and mid, and let's initialize answer with minus 1. If I didn't get any speed, then obviously the answer will be minus 1. Okay, now int n is equals to distance dot size, means it is the number of trains we have to change. Now while low is less than equals to I, not is equals to low plus I minus low I2. Now I take a time variable time taken is equals to 0 0.0. Okay, so for int I is equals to 0, I less than n, I plus plus, what I have told you, if it is not the last journey, if I is less than minus 1, I will have to take it in integer form, because we can depart only at an integer hour. Okay, so I will have to take seal of, and better to take and one of the method to take seal is this. This is the seal distance. Means if I just write distance I by mid, then that will be the floor. But if I write in this manner, then this is the seal. Okay, seal value. And suppose if it is the last journey, then it doesn't matter. I can take it in double or okay. I just typecasted it. So now if sorry, it should be time taken. So if time taken is less than equals to hour, so I can reach the office on time. So this can be the my possible speed. Okay, and now I will have to try for a lower speed because I have to find the minimum integer speed. And if I am not able to, then to reach the office on time, so obviously I will have to increase the speed. And finally I will return the answer. Yeah, it is giving right answer. Let's submit it. So it got accepted. So let's discuss the time complexity. Obviously it quite obvious that it would be big of log n log n. Why? Log n for the binary search, but to compute the time for each of the cases it would be n log n. Okay, because I am running a loop for n also. Okay, so n log n is the time complexity where the uh, it can be 10 to the power 7. It can be 10 to the power 7. So but in the interview you can tell it as n log n itself. And the space complexity is obviously big of 1 because I am not using any extra space. I am not using any extra space. Thank you.